Okay, this is section 5.2. It's sum of difference identities. So basically what you're going to do is you need to have your salmon sheet. The goal of this section is for you to find the formula that you need to deal with on the problem, write it down, and then fill in what's missing. Okay, that's basically the goal of the entire section. In order to do this, I mean, the three things we're going to do is we're going to find exact values, we're going to show that some trig statements are true, and then we're going to simplify a few things. But in order to do any of those, the important thing is to find the identity. So these are the sum difference formulas that you will find on your salmon sheet, just below the Pythagorean ones on the left side. Recognize these, know what these are going to be, and I'll show you how these work in a mere second. Okay? So the goal that you have, basically, if I say find the exact value for each thing, and I give you sine of 75, you need to think of a sum or a difference of two nice numbers that either add or subtract to 75. What I mean by nice numbers is special triangle numbers. So I always think or keep in mind of the 30s, the 45s, the 60 degrees scenarios, and see if that can kind of ring a bell for you. So what I've done here is I've kind of taken a picture of sine, sum and difference formulas, which one seems to work the best. So when I look at this, I see, all right, 75, I could break that down as the sine of 30 plus 45 degrees. So I can treat this as a sum identity, okay? So whenever I figure that part out, I instantly go to my formulas, the sum identities, and let's write that guy down, okay? So sine A cosine B plus cosine of A sine of B. And everybody's going, oh my goodness, what are you doing, Wilson? All I'm doing is I wrote that formula down. Now I'm going to get rid of this so I can write. And what I mean by A and B is the first angle. Okay? This is your A. Here's your B. So now I can instantly put that in. And I can see that sine of 30 degrees cosine of 45 degrees plus cosine 30 degrees sine 45 degrees. Now all you got to do now is go to your special triangles and write this stuff down. So if you don't remember what sine of 30 is, you need to draw your triangle out and do that. But sine of 30 is indeed 1/2. Okay, cosine or sine of 45, either way, is root 2 over 2. Okay, this is going to be root 3 over 2 times root 2 over 2. So all I'm doing is evaluating each part of this formula separately from a special triangle. And now you multiply this stuff together. I now have root 2 over 4 plus root 6, because root 3 times root 2 is root 6, over 4. Common denominator. I now can add these two together. All over 4. Cannot simplify any more than that. I'm all done. Okay? So that's as simple as it needs to be. Find the formula that it is, plug the angles in, simplify them out, and then just combine the like terms. Now, if I give you radians, technically you should write it out as radians, but I'm going to tell you right now, if you can figure it out using degrees, do that. It just works better. So this is, if you do the formula, 105 degrees. Okay? So how could I split that up? I could say that this could be cosine of, 60 degrees plus 45 degrees. Okay? And if I know that I'm using a sum, not a difference, the sum one, I need to write that formula down. Now I'm going to kind of skip steps. This is my A, here's my B. So I'm going to go, this is equal to cosine 60 degrees, cosine 45 degrees, minus sine of 60 degrees, sine of 45 degrees. Okay? So that was my sum formula. Now I just got to do the same thing I just did on the previous problem. So I'm going to say that's equal to cosine 60. Cosine of 60, 1/2. Root 2 over 2 minus sine 60. That's root 3 over 2. And that's still root 2 over 2. So now I do the same drill. This is root 2 over 4. That's root 6 over 4. And then you can combine those together to be root 2 minus root 6 over 4. That's my exact values. Dunsky. All right? So that's kind of how that works. If I just give you some of those problems. So let's just try to break it up, find the formula, dump the stuff in, and solve. Okay? So that is finding exact values. The next couple are to show that something's true. Basically, it's kind of like a proof. Okay? If I give you a sum formula, go find it. We're hoping to show that it's just cosine theta at the end. So here's my sum formulas. I'm going to write that down. This is my A. This is my B. Okay, so this is going to be equal to cosine. A in this case is actually x. And then it's cosine of B, which is just 2 pi, minus sine of A, which is x, sine of B, which is 2 pi. Oh my. The cosine x and the sine x, you can't touch that. But what is 2 pi? 2 pi on a unit circle is straight, right? Then the coordinate point is 1, 0. So I know that my cosine is 1. So I'm going to go cosine x times 1 minus sine x, though sine at 2 pi is actually 0. Well, that makes all that go away. And what are you just left with? 1 times cosine of x. Winner. Okay? So once again, it's just recognizing what is the formula you need, dumping it in, evaluating out. Good things tend to happen. Okay? Now I'm going to show this one. Now I'm going to the tangent formula. So you guys got to know what the tangent formula is. Okay, tangent, subtracting tangent. So if you go to the difference of tangent formula, that's going to be tangent A minus tangent of B over 1 plus tangent A, tangent B. So in this scenario, here's my A, here's my B again, and we got to show that this is true. So if I dump all this in, tangent of A, so that's tangent x minus tangent of pi over 4 all over 1 plus tangent x tangent pi over 4. So I've dumped all that in. The only ones that we can't change the x's. The only thing we can change are the pi over 4s. Well, pi over 4 is 45 degrees. That's a 1 squared to 2. What's tangent there? Opposite over adjacent is just 1. So everywhere I see tangent pi over 4, I can rewrite it with a 1. So tangent x is staying minus 1 over 1 plus tangent x times 1 is just tangent x. Now, does that look very, very similar to what I need? Yes, because with an addition sign, I can move those around. Okay, so I could write this as tangent x over 1 over, and I could just switch the order, and then it looks exactly the same. All right, smiley face there. Okay, here's another way. I just want to rewrite it, okay, as a single cosine. All that means is you're taking the difference formula and you got to shove it back to where it is. So in order to do that, you just need to recognize, is this a sum or is this a difference formula? Okay, so I have cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. That means I have a cosine sum formula. Okay, if you can recognize that, it becomes really easy because here's your A, here's your B. Same A, same B. So what you need to do now is, okay, I know that it's cosine of A plus B, whatever your A plus B is in the problem. So in this case, it's cosine of 3x plus 2x. And you can add those up because they're like terms, so it's cosine of 5x, and that's your single cosine. Okay? So that's me specifying its cosine. Now, if I say write as a single trig function, you guys got to go find it. So in this case, I see sine cosine plus cosine sine. Go to your formula sheet. Obviously, I give it away here, but sine cosine plus cosine sine. So I know that it's a sum sine formula. Okay? So I'm going to go sine of A plus B. That's all it is. That's the single trig function. So here's my A, here's my B. So I know I'm adding them. I know it's going to be 7x in the end. So whether you write it as sine of 5x plus 2x, and then we go sine of 7x. So if I say write it as a single trig function, I've given you the formula. You now need to go find out which one it is, and then simplify down. Okay? Ooh, here we go. 4 of them left. I lied. 3 of them left. I'm doing 1 sine, 1 cosine, and 1 tangent given different scenarios, okay? So here is the initial setup of the problems. I tell you that sine A is 3/5 when A is in quadrant 1. So what I tend to do is draw these out so I have a visual. So if I know I'm in quadrant 1, I'm here. Okay, my sine A, so this is A, and sine is 3/5. What does that make the bottom? Hopefully you recognize that it's 4. You can use Pythagorean theorem and check me on that if you want. My B is -5/13 in the third quadrant. So third quadrant, B, -5/13 because it's cosine. Okay, and then what does that make this one? Hopefully you recognize 5, 12, 13, and the 12 is down. That's why it's -12. Okay, so I like giving me these visuals to help me on these problems. So now what I need to do is I need sine of A plus B. So I need to go to my salmon sheet. The sum sine formula equals what? It's sine A cosine B plus cosine A sine B. Okay? And I have to go find all of them with the given triangle that they ask for. So sine of A, I know that because it was given, but you could go to the A triangle. Sine is 3/5. Cosine of B, which is over there, is -5/13. Plus cosine of A, so the cosine of this A1 is 4/5, times sine of B, -12/13. And now you guys just need to simplify. Okay? So now I have on the first one -15/65, I believe that is, plus a -48/65. Since my denominators are the same, I can combine them. And that's -63/65, and you're done. Okay? So once again, it's all about a mattering of finding that formula you need to use. You just plug the stuff in from the picture, and you simplify. Okay? Overall, these aren't overly hard. It's just once you find the formula, it's the same drill. So difference of cosine. Go to your salmon sheet. That's cosine A, cosine B, plus sine A, sine of B. Okie dokie. Sine or cosine of A, cosine A, 4/5. Cosine of B, -5/13, plus sine of A, 3/5. Times, what do we got? Sine of B, -12/13. And it's the same thing. So I have -20/65 plus -36, I think, over 65. And when you combine them together, -56/65, and you're done. Okay? So I'm finding these sum formulas from information given within the problem. So the only way you really get the answer is if you recognize where I'm drawing this. The big thing is making sure it's -12 there. Okay, making sure you have the right signs and the right sides. That's why I like setting this stuff up first, and then plugging in actually is pretty easy. Okay, let's do the very last one. All right, so I'm going to find a difference of tangent. Okay? So I believe it's the same setup. Okay, so it's actually the same drawings as I had on the previous problem. Okay, sine A is 3/5 and cosine B is -5/13. So I'm going to use the same pictures as I did before. I even have the formula sitting right here. So I'm going to go, this is equal to tangent of A minus tangent of B over 1 plus tangent A tangent B. All right. So how am I going to dump this in? Tangent of A. So if you guys go back to the previous slide, your tangent of A ends up being 3/4 minus, all right, tangent B, if you go back to the previous slide, the tangent is -12 over -5. So tangent in the third quadrant actually is positive. So it's minus from the formula. This part is actually positive 12/5. Okay, over 1 plus, and then I need to multiply these two things together, the same two things we just found. So 3/4, because that's tangent A, times tangent B is 5/12. All right, now there's about 3 ways that you guys can solve this. You either could combine the top using a common denominator, Okay, combine the bottom using a common denominator and then flip it. All right. What I like to do is just get these things simplified. So 3/4 minus 12 over 5 over 1 plus. Get these things put together just so you have a denominator of this part. So that's what, 36 over 20. I like to just multiply every single term by your common denominator of the whole works. So this is like over 1. So I have a 4, a 5, a 1, and a 20. What's the common denominator of a 4, a 5, a 1, and a 20? Hopefully you all are thinking a 20. Okay, all of these go into 20. So you can get rid of the whole fraction stuff if you multiply every term, top and bottom, by 20. It just makes the whole problem a lot easier if you can recognize it. Okay, so 4 goes into 20 5 times. 5 goes into 20 4 times. 1 goes into 20 20 times, so that's 20, and then the 20s cross out. Okay, now when I rewrite this, I have 5 over 3. What is, or 5 times 3 is 15, minus 12 times 4. What is that, 48? Over 20 plus 36. Okay, and then you just got to add and subtract on top and bottom, and you're done. So 15 minus 48 is negative 33. 20 plus 36 ends up being 56. All right, that's by far the most difficult problem just because of the simplifying. And I showed you what I think is the easiest step. But if you guys want to go try it on your own the way you want to, by all means do that. All right, so once again, this whole section's all about finding the right formula, plugging it in, and then just simplifying out. And we will practice a lot more of these in class. So I hope you guys have a great day.